In this module, we're going to build out a private blockchain implementation on Salesforce. You'll see a combination of declarative constructs and code. For those of you who are primarily admins and less familiar with Apex, don't fret. While you may not follow all of the code in detail, I think you'll find the explanations of the code easy to follow. In any case, I am going to assume that you are familiar with the basics of development in Salesforce. So I'll be showing you objects, fields, validation rules, and other declarative constructs without walking you through the process of creating them. For Apex developers, I'll assume you know how to create and edit classes and triggers and are familiar with the Apex language. In short, this course is not designed to teach beginners how to develop on the platform. There are other courses here on Pluralsight to help you with that, including my own Force.com and Apex Fundamentals for Developers course. But before doing any development, whether declarative or code, it's important to take some time to design the architecture of the system, to consider how it should work, what the data structures should look like, and how the solution should be built. When I started looking at this problem, it was clear that there was one key decision to make, and that I could go in two different directions. It's important that you understand both of those approaches, as neither of them is right or wrong. The question at hand is this: how are new blocks added to the blockchain? A blockchain is immutable, but that only addresses tampering with existing blocks. It is essential that new blocks be inserted correctly, and that they only come from authorized and trusted sources. As you recall from the last module, while our blockchain will be published and available to outsiders, those copies are purely read-only. New blocks can only be inserted from within the organization. A block will be represented by a record in the Salesforce database, a custom object, and the various blockchain hash values will be fields on the custom object. Those fields must be set anytime a record is created. So we have two challenges: determining who can create records and making sure that the blockchain fields are initialized correctly. How are records created in Salesforce? They can be created from the user interface. They can be created declaratively. They can be created through data APIs and data tools, and they can be created through Apex. Of these, all of the approaches respect Salesforce security except for Apex, which can bypass security configuration if necessary. So clearly, Salesforce security can play a role in who can create records. Apex can also use code to restrict who can and cannot insert blocks by monitoring record creation and triggers and raising an error when any attempt is made to add an illegal block. With this background in mind, let's look at the two fundamentally different approaches we can use to add blocks to the blockchain. One option is to plan on using Apex to create all new blocks. An Apex function would be called with the transaction data, calculate the hash values, and insert the record. The hash fields on the custom object must be present for the insertion to succeed. Calculating the various hash values is not hard to do in code, but anyone trying to enter records directly would have a hard time. They'd have to enter them because the Salesforce UI enforces that for required fields. An Apex trigger would validate the fields to make sure the entered values are correct. It would be impossible for processes, flows, and other declarative constructs to add records. They can't calculate the hash values. Toss in security configuration, blocking profiles from updating and inserting records, and you can do a very good job of restricting record creation to API access or Apex. And because the data APIs respect Salesforce security, blocking all profiles from creating block records will effectively lock them out as well, unless you give your API users administrative access. This approach is effective at limiting block creation to Apex. It's up to you and your own business processes to decide when to invoke that Apex functionality, including providing ways to call these Apex functions from processes, custom actions, or other mechanisms. There is a second approach for adding blocks to the blockchain. You can implement an insert trigger that automatically populates the hash values for a record when it is inserted. In this case, the hash fields are not defined as required, so users and declarative constructs can easily insert records. So you have a great deal more flexibility to define your block creation process declaratively, using clicks, not code. This approach relies almost exclusively on Salesforce security to control the ability to create new records, though of course you can implement additional security inside of the Apex trigger, even using custom permissions, a feature in Salesforce that allows you to define your own security permissions. How you'd configure security depends on your own process, but it's clear this approach offers more flexibility at the cost of being possibly less secure. But security is relative. Less secure in this case may well be secure enough, especially if you have other mechanisms in place to monitor and audit the creation of new records. So that is the choice. Require all hash fields to be calculated when a record is inserted and verify those values during the insert trigger, or allow a record to be inserted with transaction data only and set the hash values during the insert trigger. Both approaches ensure that blocks will be inserted correctly. One approach is somewhat more secure, and the other makes it easy to insert records declaratively. Neither approach is right or wrong. It's not clear that one is inherently better than the other. For the purposes of this example, I have chosen the second approach, setting hash values inside of an insert trigger. I chose it primarily because it lends itself better to experimentation. You'll be able to test the solution by inserting records directly and seeing the results. You'll see how easy it is to add records declaratively, assuming your security settings allow it. There are other design elements in this solution that would be common to the Apex-only approach. For example, you'll see how database locking can be used to eliminate the risk of contention, two asynchronous operations trying to add a record at the same time and resulting in an invalid chain. You'll see how an update trigger can be used to enforce immutability at the technical level. Anyone wishing to tamper with the ledger would have to find a way to not only change security settings, but also disable the trigger. Not an easy thing to get away with in a production org. With the architecture and high-level requirements defined, it's time to look at the data structures.